Hello, everyone. Welcome to this webinar session. My name is Armelle Chavanet. I'm the marketing manager for SLS activity at Prodways. Today's session will focus on how to make SLS production even more affordable. And it will be the occasion to present you the Prodways new SLS printer. I hope everyone managed to connect and can hear us. If you have any troubles, don't hesitate to use the chat box. So just a quick reminder on the webinar organization. During the whole session, your microphone will be muted for all participants. But feel free, as I said, to use the chat or ask your question in the question tab. For your information, we will have a Q&A session at the end of the presentation. So if everyone is ready, we can start the presentation. So today our speakers are Sylvestre Perrin, which is our CEO at Prodways Printers SLS, and Adrien Ragot, which is a business development manager at BASF Forward AM. For the agenda, you will have a quick introduction of both companies. Then we will talk about some key figures on the AM market and introducing, of course, Prodways new printer features and benefits. And finally, we will tell you how, together with BASF Forward AM, we can provide an affordable solution for SLS production. So, Sylvestre, I let you introduce Prodways activity.
Thank you very much, Armelle. So indeed, just to tell people a little bit about Prodways, our activity started initially in 2014 with printers. This is really the core of our operations. We started initially with resin printers, and then we moved on to powder printers. The business was then expanded upstream with the integration of the software companies, and downstream with the integration of service bureau and dedicated manufacturer of 3D printed parts, especially for medical application. And today, Prodways is serving around 10,000 customers in 30 different countries. We produce 3 million parts per year for a turnover of 57 million annually.
All right. Thank you, Sylvestre. And as for BASF, so BASF, we are a German headquartered company. We make chemicals. We have many divisions. We make petrochemicals down to chemicals for the cosmetic industry, for agricultural solutions, we make coatings, we make plastics, we make all sorts of chemicals. And since 2017, we have a division dedicated to additive manufacturing. It's called BASF Forward AM. It's rather young, but already we have dedicated materials for the 3D printing industry. And we have powders, filaments, including metal filament, photopolymer resin. So we have materials for the whole range of polymer technologies in 3D printing. We also have additive manufacturing services and our own consulting office to develop applications together with our partners. And in services, I can also include Sculpteo, which is our internal, our printing office, purchased or acquired in 2019 and now fully part of BASF. So having all these range of materials, we often work with machine manufacturers such as Prodways to co-develop materials specifically for a certain machine material combination, and this is what we did in this specific case with Prodways, and we have a very nice solution to present to you today. Back to you, Sylvestre.
Thank you very much, Adrien. So I'll start with a brief glance at the additive manufacturing market, because this market is a very fast-growing market. Actually, if we look at the industrial part production through 3D printing during the period spanning from 2014 to 19 that we have on the graph, the growth was over 200% in 5 years. And today, as you can see, end-use parts represent 31% of the applications in additive manufacturing, against 25% only for functional prototypes. And additive manufacturing was designed and invented initially for functional prototype, but now we've seen that the end-use parts are taking over, and the majority of application is to be found among industrial application. So to keep growing in this market, additive manufacturing players, they focus on technology improvements such as the speed, but also new application and new materials to fit with different industrial needs. So for this reason, on the market today, people can find large-scale industrial SLS printers that are designed for industrial productivity. And more recently, we've seen appearing compact SLS printers, which are more geared towards desktop type of application, but have limitation in terms of the size of parts that can be printed. What Prodways has decided to do is to position the printers among industrial printers, so with a large chamber, a high speed capacity, but with a lower investment required to get the machine on board. And our mindset and our objective is really to open SLS industrial production to new players, to new applications that could not afford this technology before. How we've done it for the P1000S, which is the product that we are launching today. It's not only a product, actually, it's a very nicely designed printer, as you can see on the left of this slide, but it's also a fully validated solution with materials, processes, software, and a full workflow that is able to meet the requirement for industrial production. And we want to present this in detail, which is what I would like to cover in the next slide. So to start with, the first word I'll start with is reliability, because in industrial environment, it's very important. When you build prototypes, you have machines that can fail, you have production that can be delayed, that's not a problem. If you build mass production parts, that's certainly not acceptable. So you need a proven technology. And here we have the know-how of our Prodways engineer. So we build on generations of previous printers that Prodways have developed to launch this new printer P1000S. It's using a recoating system that has a counter-rotating roller to avoid crashes during the production and makes the print run smoothly. It has also independent heater system and an advanced field control thanks to a thermal camera. It's actually the same proven system that we were using for our P1000X printer previously. It's also a high quality engineered piece of equipment. I'm very proud to say that it's manufactured in Annecy in France, right in the factory where I'm speaking from. It uses very proven and reliable components such as US-based laser scanner, US-based galvo. It has an integrated nitrogen generator, so very very high quality components, and it's also using Prodways software expertise. So we've got, for example, a built-in recording system that allows a better post-processing control, because you can provide documents to the end customer proving how parts were built, the time, the process, the number of layers, and so on and so forth. This is all recorded in the software. And of course, if we speak about software, we speak about parameters, and this machine comes equipped with parameters for different materials: PA12, PA11, TPU, and PP. And this whole set here will allow industrial manufacturers to produce high quality parts. It's also not only it's technically advanced, but it's also very user-friendly and flexible. For example, the machine itself has been designed so that the build platform is easy to access, easy to maintain. We, of course, offer an application support with our dedicated team, and the machine is very easy to use. It has a friendly user interface. It has remote support, so you can communicate with our team that can have a live access to the machine, and especially we can use a live camera that is integrated in the machine, so that our support team can really see in detail what's happening in your production premises. And finally, it's a very flexible printer. Just to give you a couple of examples, it can slice parts on the fly, which means that we can add new parts even when a build is already started to run. We also don't need to refill material during production, which is sometimes a drawback with some other machines on the market. And finally, in terms of flexibility, we give access to over 50 parameters to our users, so that they can, really fine-tune and adjust the machines to their detailed. So I mentioned also earlier that it's an industrial printer, and on the next slide I'm going to explain why. This machine offers a build volume of 300 times 300 times 360, which means 32 liters, and that's just the best price over build volume ratio in its category. So it's also very fast, because production preparation can be done in less than 10 minutes, including cleaning, nesting, and so on. And the printer can go very fast with adjustable layer thickness. You just need a few hours to complete a job. So this is really an industrial printer that has been designed and built for productivity and for industrial companies that are looking to achieve mass production volumes with that. And of course, when I say it has the best price volume ratio, it means that our price is really an aggressive price. The machine sells for 117,500 euros, $129,000 in North America. And it's not only about the cost of the machine itself. It's a matter of total cost of ownership for us, which means that the package, the hardware package that is required to operate the machine is also very cost competitive. The maintenance contracts are very cost competitive, and the parameters for different materials are provided free of charge, and the support is also very cost competitive. So with all this cost maintained to a low level, what we want to achieve is to allow customers to actually scale up their production to be able to buy several printers to expand their production, because the printer is affordable. This gives the opportunity for people, for example, to have 2 printers running 2 different materials, which is much more comfortable rather than having only 1 printer, which you need to clean and lose a lot of time between 2 print runs if you want to swap materials. So the cost picture would not be complete if I did not mention our PP material, which we have developed for this printer in partnership with BASF. And PP is also a very affordable 3D printed material. So I'll hand over to Adrien for him to present the specifics of PP material.
Thank you very much, Sylvestre. So let me introduce you to PP 1200. And to do so, let me tell you a bit of the story of how and why BASF developed polypropylene in the first place, and in this case, PP 1200 with Prodways. So this is what you can see now is the polymer pyramid. You may be familiar with it. So for those who don't know, on top you have the more expensive and advanced plastics, and on the bottom you have the more affordable standard plastics that are much more commonly used. And when it comes to powder bed fusion and SLS, specifically the focus area or the focus materials used are in the middle of the pyramid. They are PA11, PL12, mostly they are widely used, even though in standard manufacturing, those materials are almost non-existent. Nobody is injecting PA12 or PA11, for instance. So the idea to also talk about, to bring affordability to 3D printing is to be able to print a material from the bottom of the pyramid. And this is why BASF got interested with polypropylene specifically. Polypropylene is widely used in automotive, in cosmetics, in packaging also, and it's affordable, and it has also some very specific characteristics that make it interesting as a material for 3D printing. So now we have it. We have this this new material, and we can unlock new potential applications that are derived from the standard manufacturing that uses polypropylene already. And talking about the specificity of polypropylene, it's not just because it's affordable, it also has some very interesting or very essential properties. To finish on affordability, I want to mention that not only the raw material is cheap, but also the density of polypropylene is lower. It means that if you want to print the same volume as for PA12, you need less kilograms. And so it's also a way to have a cheaper part. But also the refresh rate is quite good. So then also when you do the next job, you don't need to add as much new powder as you need for other materials. So this is, all of this is our ways to bring the cost down also with PP 1200. But PP is also has also some those other characteristics, as you can see here. First of all, the chemical resistance, that's probably obvious for those who know the chemistry of it. So PP can be used together with many different oils, acids, bases, many different chemically aggressive products. So to use it with as pipes or tanks, reservoirs, different kinds of parts that needs to be in contact with aggressive fluids or just fluids, it's a great material for that. Also because it has a low moisture absorption, so even in time, and this is also to do with the durability, the polypropylene part will not degrade. The mechanical properties will remain. So for this kind of parts, it's a great material, and it also is a bit translucent. So if you have a container and you fill it with some kind of liquid, you can already see through the material and see if your container is empty, full, or half full. etc. Looking at the specific material properties, it has also some specificities, so a higher elongation at breaks, or to say it simply, it has a bit elastic, it bends a little, which is great for the clips or any kind of part that needs to have a little bit of flexibility. Finally, and this is quite important, I want to talk about recyclability. And this has to do with the fact that PP is again, it's a standard plastic. It's widely used also for packaging, so it can be recycled. So it's hard for me to make a global statement, but I would say that many countries, or in many countries, you can put a PP part in the standard recycle bin at your home or in the street, and it will be recycled together with the many PP packaging parts that are put in there as waste. So well, it's kind of obvious what the advantage is here for a sustainable story around a part made in polypropylene. It has a great advantage compared to other materials. So PP 1200 is a great material for both the affordability and also for the specific mechanical properties or material properties. It can unlock new potential, and it can be an alternative to PA12 and PA11. Thank you. And on this next slide, I want to talk a bit about the post-processing that can be done with polypropylene, and it's we have a specific material, so we have very specific post-processing there. First of all, the welding capabilities, and here you can see a list, a very long list of welding technologies that we tested. All work just fine with polypropylene, and this is great because with polypropylene you can weld 3D printed part together and make something even more complex, or you can weld a 3D printed PP part with an ejected part in polypropylene, which is also a very nice feature. If you want to, again, bring the cost down, you can make part of your part in PP, injected PP, and the rest in 3D printing, and you can weld those parts together nicely, and it works really well. Vapor smoothing is also a very nice topic, and look at this very nice picture. In this case, I mean, vapor smoothing for PP is not so obvious because of the chemical resistance of the material. So we were very positively surprised when we saw this job performed by AMT Post Pro. It's them who managed to find a way to do this vapor smoothing on polypropylene, and already polypropylene is a bit translucent, but here you can see how even more translucent it becomes. It's a very nice part. You can really see through, and the roughness also decreased. So it's really nice that we can have that kind of finishing for a part in polypropylene. And finally, talking about coating and gluing, it's again the same topic because polypropylene is chemical resistance, not so easy to do. But so for coating, we managed to find a way to do it. We have this product called Ultracure UV Adhesion Promoter. It's a primer. You can spray it with a spray gun on top of your part before you apply any standard top coat, whatever color you can find on the market, and it will make sure that the adhesion between the top coat and the part works fine. And it does work really fine, which is great. You can now have a PP part in the color you want. For gluing, it's a bit of the same topic, not so easy because of the chemical resistance. We do not have the official results yet, but I can already tell you that we found a technical solution. We are quite positive that it's going to work really well and that we can share the positive results shortly. So now we also have a solution to glue PP parts together. So in conclusion, PP 1200 developed by BASF for the P1000S is a great material, allowing to unlock a new potential for SLS applications and new applications because of the specific properties of PP, and also because of the affordability of the whole solution. And so we are very glad that we can present this material together with Prodways today. Thank you very much, and handing it back over to you, Sylvestre.
Thank you very much, Adrien. So, yeah, as you say, this is really the perfect solution, and we are convinced that we have the perfect printer to start or expand industrial SLS production. We will start shipping the machine by early Q2 next year. So if you can't wait to have a Prodways printer, I can only recommend you the P1000X, which is in part of the same family of with this printer, and that is already sold and available.
Thank you very much for your attention. I hope you enjoyed this presentation. If you have any question, don't hesitate to use the question tab. And by the way, I have a few questions for you. So let's start with a question for Sylvestre. So Sylvestre, you told us about PP. Do you provide validated parameters for other materials?
Yes, indeed, we have worked with BASF to fully validate parameters for PP, which, by the way, it's not easy because PP has a very tight fusion window, so it requires a lot of attention. But we've already validated PA11, PA12, and TPU as other materials. So PP is definitely not the only one. And I have to add also that because the P1000S is a very easy printer or easy to maintain and easy to clean, especially, it's easy to swap materials with this printer. So you can use the different materials that I've mentioned on the same printer if you want to.
Okay, thank you, Sylvestre, for the answer. I have one question for Adrien. So, Adrien, you told about the low cost of the PP. Do you have an idea of the cost of a printed part in a centimeter cube compared to other material? And also, can you tell us the refresh rates?
So the refresh rate can go up to 60-40, so 60% used powder and 40% old powder. Regarding the price per cube centimeters, I don't have it, and also I would not have it specifically for the P1000S printer. You have to understand that we work with many different printer manufacturers, and this is not a general value that we communicate, though I understand how interesting it could be. But unfortunately, I would have to give it a bit of thought and answer in writing.
Okay, thank you very much, Adrien, for this question. So I have many questions, sorry. Thank you for your interest on this printer. So one question for Sylvestre. Are users able to change the process parameters themselves, or is the printer locked?
Yes, I'm positive about that. As I explained, we have more than 50 parameters that are adjustable. So we don't, when we sell a printer, we don't want a customer to be locked. We have standard parameters that have been developed for the different materials: PP, PA12, PA11, TPU. And these are delivered free of charge with the machine. But people can also play with these parameters if they want to build other type of production, or if they want to play with the parameters.
Thank you, Sylvestre. I have another question on the printer. How long does it take to do a full build?
It's difficult to answer this question because it's depending on the size of the part, the geometry, the layer thickness that can also be adjusted. I would say this machine, the speed is up to 1.4 liter per hour. So depending on the material that you are running, you could run a full job in 24 hours. We've done examples where for a job that you run for nearly the full height of a build, which is 360 millimeter, if you select 0.1 millimeter as layer thickness, with 7% of nesting density in your build, for PP 1200, you will have 23 hours of fabrication, so a little bit less than one full day.
Thank you very much, Sylvestre. And another question, how do the, so compared to HP MGF, do we have any comparison on the cost per part basis? But
as I said for the previous question, it's tricky because the geometry of the part will influence that, and even for a part that has a volume of 10 cubic centimeter, for example, depending on the shape, the cost will change. That being said, we are willing to assist customers in calculating their cost. I know that there are a lot of tools on the market that help people to calculate the cost for their additive manufacturing parts. Some of the tools sometimes do not take into account factors such as labor and utilities, for example. So we try to be quite comprehensive, but yeah, I'm sorry to say this needs to be done on a case-by-case basis, and we'll be happy to assist on an individual case.
Thank you for your answer. Another question, did Prodways propose in their package the qualification of their 3D printer for a medical device factory?
I would say this is depending on the material and also depending on the type of application, because there is a wide variety of things that are being called medical. We are, routinely selling to people that build parts to be assembled in medical apparatus, such as scanners, for example. On the other hand, if you are thinking, if for you medical means implants, then this is a totally different story. We know that among the material that we offer with our line of powder printer, PA11 especially is more suitable for medical type of application. But again, we need to look in detail to your application to see, okay, is it touching the body? Is it going to be in contact with the skin or not? There are a lot of criteria to take into account within the medical world.
Thank you very much for your answer. I received lots of questions, and no worries, we will come back to any of you, but we are running out of time. There is one last question, and it's for me, actually. Is it possible to show images of the new printer again for latecomers? So no worry, latecomers, this webinar has been registered, and we will for sure share the replay. It will be available in the next days. And again, thank you very much for your attention, and thank you for all your questions. We are very pleased to see the interest on our solution combined with BASF, and we will keep. We will come back to you soon to answer the last questions. And thank you very much for the speaker for this presentation.
Thank you very much, Armel, and thank you to everybody.
Thank you, Armel. That was a pleasure. Thanks, everyone.